Welcome to EDU World Space.
So, in problem number 81, right? Um, it is given to us that if the yield stress, right, sigma sub y is equal to 50 ksi, we need to determine the factor of safety for this loading against yielding based on we have two parts, right? Part A is a maximum shear stress theory, and part B is the maximum distortion energy theory, right? So let's start with part A. Now, the solution for this question is very simple. Now, according to the figure of the problem, we are given that sigma sub x is equal to negative 20 ksi, sigma sub y is equal to 12 ksi, and torr sub xy is equal to 10 ksi, right? So now for part A, we need to solve this problem using the maximum shear stress theory, right? So it means that we need to use the equation 10.27 to determine the correct version of this equation for this case. First of all, we need to find out the principal stresses, right? The principal stresses sigma 1 and sigma 2, right? So let's start with sigma 1, and for that we will be using equation 9.5, right? So let me use a different color. So sigma sub 1 is equal to sigma sub x plus sigma sub y divided by 2 positive under root sigma sub x negative sigma sub y divided by 2 parenthesis square plus sub xy square, right? So just plug in the values. I'm not going to plug in the values over here. I'm going to skip one step because it's very simple. It's just like plugging in the values, right? Writing the values, given values, so you can do them by yourself. Now I'm going to write the calculated value of sigma sub 1. So that is 14.8680, and that is approximately equal to 14.87 ksi, right? Now we need to solve for sigma sub 2, the other principal stress. So the equation for sigma sub 2 is sigma sub x plus sigma sub y divided by 2 negative under root parenthesis start sigma sub x negative sigma sub y divided by 2 parenthesis close square plus sub xy square, right? So again, I'm not going to like plug in the values. I'm going to skip that step. You can do it by yourself. I am just going to write the calculated value of sigma sub 2, right? So that is negative 22.8680, and that is approximately equal to negative 22.87 ksi, right? Now we have the value of both principal stresses, right? So as you can see that they are opposite in signs, they have different signs, right? One involves a positive sign and the other involves a negative sign, right? So now we would be using equation 10.27, right? So sigma sub y is equal to the absolute value of the difference of sigma sub 1 and sigma sub 2. Just plug in the values and we'll get that sigma sub y is equal to 37.74 KSI, right? Now as you can see that this calculated value, right? This calculated value that is 37.74 KSI, it's less than the given value that is 50 KSI. So it means that then the material does not fails does not fail according to the maximum shear theory, right? According to maximum shear stress theory, right? So it means that we can find out the factor of safety, right? So let me use a different color. Now the factor of safety, let's call it K. It's the ratio of the maximum yield stress the material can endure to the one enduring it. It means that sigma sub y sub material divided by sigma sub y. Just plug in the values. So we have K is equal to 50 divided by 37.74. That is equal to 1.3263. That is approximately equal to 1.32, right? So this is the solution for part A. Now next we have to solve part B, right? So in part B, we need to solve the factor of safety using or considering the maximum distortion energy theory, right? So now it all simply needs the principal stresses, right? And we just calculated them. We have the value of principal stresses. So now we are going to simply use the equation 10.30, right? So here sigma sub y square is equal to sigma sub 1 square negative the product of sigma sub 1 sub 2 plus the square of sigma sub 2, right? We need to take under root over here because we have a square on the left hand side, right? So for that we need to take the under root. So when we'll take the under root, we'll get sigma sub y is equal to sigma sub 1 square negative sigma sub 1 sub 2 negative sigma sub 2 square, right? So just plug in the values and we'll get that sigma sub y is equal to 32.9242. That is approximately equal to 32.92 KSI, right? Now as you can see that this new found or this calculated value, this 39.92 is less than 50, right? So it means um, that the material does not fail, right? And according to distortion energy theory, so again the factor of safety for this case, it would be 50 divided by 32.92, that is equal to 1.5186, and that is approximately equal to 1.52, right? So this concludes our answer for part B.